All right, let's have a look at simplifying surds. Simplifying surds is quite an essential skill because you need it in order to add, subtract, multiply, and divide surds. The ultimate goal, so what you're trying to do when you're simplifying a surd, is to make the term or number underneath the square root sign as small as possible. And we do that by factorizing or by breaking up that number into smaller parts. So let's have a look at root 48. We need to break up root 48 into two parts, or two factors, one of which is a perfect square. I have the perfect squares here, or from 4 to 100. Can we use one of these perfect squares to multiply another number to make 48? So let's have a look at 4. We'll start off at the bottom. Yep, 4 times 12 is 48. So we could use that. But we need to use the highest perfect square. So let's see if there's any larger or higher perfect squares. 9 does not multiply by another number to make 48. 16 does. So 16 will be our answer. It'll be 16 times 3. So let's factorize or break up our root 48 into those two factors. I'm going to give each of my factors a square root of their own. You can do that. And now I can see root 16 can be simplified to just 4. So 4 times root 3. And using mathematical convention, I can remove the multiplication symbol and just have it as 4 root 3. So that's how you simplify, by making the term or the number underneath the square root sign as small as possible. Let's have a look at our next question here. The next question is a little bit more difficult because we have multiple terms that each need to be simplified on their own. So the first thing I'm going to do is split each of the terms up first before we simplify them. So let's split them up. It'll make it a little bit more easier to deal with individually. All right, let's have a look at root 32. So we can use 4. Yeah, 4 will work because 4 times 8 is 32. But I can see 16 here. 16 times 2 is 32. That's the larger perfect square. We're going to go ahead and use that. So let's go ahead and split up root 32 into root 16 times root 2. Now our next term is going to be multiplied by, now we have this, the square root of x cubed. Now whenever you have an odd number, I'm going to explain how to deal with it. But whenever you have an even number, there's a different strategy, which I'll explain as well. Now, each of those explanations I will do in a separate video, a more detailed explanation. But here's just the trick, or the quick way of doing it. So whenever you have an odd number, you take away 1. So this odd number here being 3, you take 1 away, that ends up as 2. Then you halve that number, so half of 2 is 1. All right, so there's your number, 1. You write the letter, so the letter is x. You write that number, 1, and then you put an extra square root of whatever that letter is. That's the trick. Okay, so again, I'm going to do another detailed explanation in another video, but that's the trick. Let's do the trick again with this next term, square root of y to the power of 5. Now, that number is odd, so we take 1 away, that becomes 4. Then you halve it, that becomes 2. And then you simply write whatever the letter is, which is y, put a 2 there, and then square root y. That's the trick. Again, another video coming up. So let's keep going. Let's write a new line. And let's see if we can solve anything else. I'm just scanning now. I'm scanning this line and I can see that root 16 can be simplified. But essentially nothing else now can be simplified. So this next line will be really dedicated towards the root 16. So root 16 can be simplified to 4. Then I have multiplied by root 2 times x to the power of 1, which is just x, root x times y squared, root y. All right, nothing else can be simplified now. So when you get to that point when nothing can be simplified, all you need to do is collect the terms that are outside the square root, so 4x and y squared, and then collect the terms that are inside the square root, so 2x and y. So I'm going to have 4x y squared multiplied by 2xy. All right, let's do this last one. But first, what I might do is I might just resize the working out on this last question so we have a little bit more room. So I'll just shove that there. Now we have more room for our last question. All right, our last question, even more complex. Reason being, we have a quarter, so a fraction, outside of our square root sign. We can't do anything there. We can't simplify it. So all we need to do is just ignore it until we can multiply it with something else. So let's just ignore it and deal with everything underneath the square root sign. So the square root of 16a squared times b to the power of 7. The way you want to treat this is that there are 3 individual terms here that can be split up into their own square root. Let's go ahead and do that. So we have 1/4 multiplied by the square root of 16 multiplied by the square root of a squared multiplied by the square root of b to the 7. All right. I can start simplifying each of these 3 terms. So we have 1/4 times, now the root 16, that can be simplified to 4. I want to make a note about this, about the position of the 4. This 4 here, this whole number, every whole number is in fact a numerator, where the denominator, and I'll use the green, where the denominator of every whole number is just 1. So I need to make sure that my numerators, or my whole numbers, are written on the same level as the numerators of my fractions. So when I wrote this 4 here, I had to make sure it was on the same level as the numerator of 1. So that makes it easier to now multiply these 2 numbers together. But let's keep going. So I'm left with, let's use the right color, times, now I have root a squared. There's 2 explanations for this. The explanation that I'm going to use now, and I'll use the second one in a minute, the first explanation is what I used previously in my other questions. So we have an even number here. So with even powers, whenever you have a square root and an even power, all you need to do is halve that number. So this number being 2, you just halve it, which is 1, and then you just write a to the power of 1. That's the trick. Now the explanation with this is quite simple for this particular one here. Whenever you are squaring something and square rooting something at the same time, well, these functions are the opposite to each other. So they just cancel each other out. So you're just left with the letter inside. So all we're left with is a, or a to the power of 1. Let's keep going. Multiplied by, now we have b, or square root rather, of b to the power of 7. Again, we have an odd number. So the trick here is we identify our number. It's 7. So take 1 away. That's 6. Halve 6. That's 3. So you write b to the power of 3, and then you add an extra root b on the end. Now, we can go ahead and simplify this first part, the quarter multiplied by 4. Whenever you're multiplying fractions, you multiply the numerators and the denominators. So you're going to be left with 4 over 4. And 4 over 4 is just 1. Now, whenever you have 1 multiplied by anything else, it won't change anything else. So you can just put a line through this and we can ignore it. So we're left with a times b cubed root b. And that's pretty much our answer, but using mathematical convention, we can remove the multiplication symbol and just have ab cubed